Electrical wiring is the backbone of modern electrical systems, providing the pathway for electrical current to power devices and equipment. Understanding the principles and practices of electrical wiring is crucial for ensuring safety, efficiency, and compliance with electrical codes. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation. It provides detailed requirements for wiring methods, materials, and equipment. Adherence to the NEC is essential for preventing electrical hazards such as fires and shocks. Electrical conductors are the materials that carry electrical current. Copper and aluminum are the most common conductors used in electrical wiring. Copper has a higher conductivity than aluminum, meaning it offers less resistance to the flow of electricity. However, aluminum is lighter and less expensive than copper. Conductors are typically insulated to prevent accidental contact and short circuits. Insulation materials are rated for their voltage and temperature withstand capabilities. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. Ampacity is determined by the conductor material, size, insulation type, and installation conditions. The NEC provides ampacity tables that specify the allowable ampacities for various conductors. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level. Circuit breakers are resettable, while fuses are single-use devices that must be replaced after they blow. Grounding is a critical safety measure that provides a low-impedance path for fault current to return to the source. Grounding helps to prevent electrical shock hazards by ensuring that metal enclosures and equipment are at or near ground potential. Bonding is the process of connecting metal parts together to create an electrically conductive path. Bonding helps to equalize voltage potentials and reduce the risk of electric shock. Wiring methods refer to the techniques and materials used to install electrical conductors. Common wiring methods include non-metallic sheath cable, or NN cable, also known as Romex, electrical metallic tubing, or aimed rigid metal conduit, or RMC, and flexible metal conduit, or FMC. NM cable is commonly used for residential wiring. EMT is a thin-walled metal conduit that is easy to bend and install. RMC is a thick-walled metal conduit that provides excellent mechanical protection. FMC is a flexible conduit that is used for connections to motors and other equipment. Electrical boxes are used to enclose wiring connections and provide a safe and secure mounting point for devices such as switches and receptacles. Boxes are made of metal or non-metallic materials and are available in various sizes and shapes. The NEC specifies the minimum size of boxes based on the number and size of conductors they contain. Wiring connections must be made properly to ensure reliable electrical service and prevent overheating. Common wiring connection methods include using wire connectors, also known as wire nuts, terminal screws, and crimp connectors. Wire connectors are used to join two or more conductors together. Terminal screws are used to connect conductors to devices such as switches and receptacles. Crimp connectors are used to create permanent connections between conductors. Electrical circuits are classified based on their voltage and current carrying capacity. Branch circuits supply power to outlets and lighting fixtures. Feeder circuits supply power to branch circuits from the main service panel. Service entrance conductors bring power from the utility company to the building. The NEC specifies the minimum size and type of conductors for each type of circuit. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock hazards. GFCIs monitor the current flow in a circuit and interrupt the power if a ground fault is detected. GFCIs are required in areas where there is a high risk of water contact, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or SIs, are designed to protect against fires caused by arcing faults. SIs detect abnormal electrical arcs and interrupt the power before a fire can start. SIs are required in many areas of the home, such as bedrooms and living rooms. Electrical panels are used to distribute power to various circuits in a building. Panels contain circuit breakers or fuses that protect each circuit from overcurrent. The NEC specifies the requirements for panel board installation, including location, clearance, and labeling. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before working on them. Use appropriate personal protective equipment, such as safety glasses and gloves. Follow the NEC and other applicable electrical codes. If you are not qualified to perform electrical work, hire a licensed electrician. Proper grounding and bonding are vital for electrical safety. Grounding provides a path for fault current to flow back to the source, helping to trip over current protection devices. Bonding connects metal parts together, minimizing voltage differences and reducing the risk of shock. The size of grounding and bonding conductors is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of grounding and bonding conductors. Overcurrent protection is essential for protecting electrical circuits from damage caused by overloads and short circuits. Circuit breakers and fuses are designed to interrupt the flow of current when it exceeds a predetermined level. The size of overcurrent protection devices is determined by the ampacity of the conductors they protect. The NEC specifies the maximum allowable overcurrent protection for various conductor sizes. Wiring methods must be selected based on the application and environmental conditions. An M cable is suitable for dry locations, while EMT and RNC are suitable for wet locations and areas where mechanical protection is required. The NEC specifies the allowable wiring methods for various applications. Electrical boxes must be sized appropriately to accommodate the number and size of conductors they contain. The NEC provides tables that specify the minimum box fill requirements. Wiring connections must be made properly to ensure reliable electrical service and prevent overheating. Use appropriate wire connectors, terminal screws, or crimp connectors. The NEC specifies the requirements for wiring connections. Electrical circuits must be properly identified and labeled. Label each circuit breaker or fuse with the circuit it protects. Use appropriate wire markers to identify conductors. The NEC specifies the requirements for circuit identification. GFCIs and FCIs provide additional protection against electrical shock and fire hazards. Install GFCIs in areas where there is a high risk of water contact. Install FCIs in areas where arc faults are likely to occur. The NEC specifies the locations where GFCIs and FCIs are required. Electrical panels must be installed in accordance with the NEC. Ensure that the panel is properly grounded and bonded. Provide adequate clearance around the panel for access and ventilation. Label each circuit breaker or fuse with the circuit it protects. When working with electrical systems, always follow these safety precautions. De-energize circuits before working on them. Use appropriate personal protective equipment. Follow the NEC and other applicable electrical codes. If you are not qualified to perform electrical work, hire a licensed electrician. The NEC is updated every 3 years to reflect changes in technology and best practices. Stay current with the latest edition of the NEC to ensure that your electrical work is safe and compliant. Electrical systems are complex and require careful planning and installation. By understanding the principles and practices of electrical wiring, you can ensure the safety, efficiency, and reliability of your electrical system. The National Electrical Code 2017 edition contains numerous tables and articles relevant to electrical wiring. For example, NEC Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in free air. This table is essential for determining the appropriate conductor size for a given load. NEC Article 250 covers the requirements for grounding and bonding. This article is critical for ensuring electrical safety. NEC Article 300 covers the general requirements for wiring methods and materials. This article provides guidance on the proper installation of electrical wiring. NEC Article 400 covers the requirements for flexible cords and cables. This article is important for understanding the limitations and applications of flexible cords and cables. NEC Article 408 covers the requirements for switchboards and panel boards. This article provides guidance on the proper installation and wiring of electrical panels. NEC Article 500 covers the requirements for hazardous locations. This article is important for understanding the special requirements for electrical installations in hazardous locations. Understanding the NEC is essential for anyone involved in electrical work. The NEC provides detailed requirements for all aspects of electrical wiring, from conductor sizing to grounding and bonding to overcurrent protection. By following the NEC, you can ensure that your electrical work is safe and compliant. Remember that electrical work can be dangerous. If you are not qualified to perform electrical work, hire a licensed electrician. Always de-energize circuits before working on them. Use appropriate personal protective equipment. Follow the NEC and other applicable electrical codes. Consider an example. A 120-volt circuit is supplying power to a lighting load of 15 amps. According to NEC Table 310.15b16, a 14 American wire gauge copper conductor with a 75 degrees Celsius insulation rating has an ampacity of 20 amps. Therefore, a 14 American wire gauge conductor would be suitable for this application. However, it is important to consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. If the voltage drop exceeds these limits, a larger conductor size may be required. Another example. A 240-volt circuit is supplying power to a motor load of 30 amps. According to NEC Table 310.15b16, a 10 American wire gauge copper conductor with a 75 degrees Celsius insulation rating has an ampacity of 30 amps. Therefore, a 10 American wire gauge conductor would be suitable for this application. However, it is important to consider the motor starting current. Motor starting current can be several times the motor's full load current. The NEC requires that the overcurrent protection device be sized to accommodate the motor starting current. In this case, a time delay fuse or a circuit breaker with an inverse time characteristic would be required. Furthermore, when dealing with electrical installations, it is essential to consider the environmental conditions. For example, if the wiring is exposed to direct sunlight, the insulation may need to be rated for higher temperatures. If the wiring is installed in a wet location, it must be protected from moisture. The NEC provides detailed requirements for electrical installations in various environmental conditions. Understanding these requirements is crucial for ensuring the safety and reliability of the electrical system. In addition to the NEC, there may be local electrical codes that must be followed. Local codes may be more stringent than the NEC. It is important to check with your local electrical inspector to determine the applicable codes. The electrical wiring is a complex and ever-evolving field. Staying up to date with the latest codes and best practices is essential for ensuring the safety and reliability of electrical systems. Consider the topic of grounding electrode systems. A grounding electrode system is a network of interconnected grounding electrodes that provide a low impedance path to earth. The purpose of a grounding electrode system is to protect people and equipment from electrical shock hazards. Common grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC specifies the requirements for grounding electrode systems. The size and type of grounding electrodes are determined by the size of the service entrance conductors. The grounding electrode system must be properly connected to the service equipment and the building's metal frame. The resistance of the grounding electrode system must be low enough to ensure that fault current can flow back to the source. Regular testing of the grounding electrode system is recommended to ensure that it is functioning properly. Another important topic is surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other events. SPD divert the surge current to ground, preventing it from damaging sensitive electronic equipment. SPD are available in various types and sizes. The type and size of SPD required will depend on the application and the level of surge protection desired. SPD should be installed at the service entrance and at branch circuits that serve sensitive electronic equipment. Regular inspection and testing of SPD is recommended to ensure that they are functioning properly. Lighting is another critical aspect of electrical systems. Proper lighting can improve safety, productivity, and aesthetics. There are many different types of lighting fixtures available, each with its own advantages and disadvantages. The type of lighting fixture selected will depend on the application and the desired effect. Energy-efficient lighting technologies, such as LED lighting, can significantly reduce energy consumption and operating costs. Lighting controls, such as occupancy sensors and dimmers, can further reduce energy consumption by turning lights off when they are not needed. The NEC provides requirements for lighting installations, including the placement of lighting fixtures and the control of lighting circuits. Electrical safety is always a top priority when working with electrical systems. Always follow these safety precautions. De-energize circuits before working on them. Use appropriate personal protective equipment. Follow the NEC and other applicable electrical codes. If you are not qualified to perform electrical work, hire a licensed electrician.